Hi Physics fam, we are going to be doing an angled projectile problem where we are solving for the peak height of a football along its path. Earlier we did two videos determining the time of flight. You can see that work here on your screen. If you need it, you can go ahead and pause it, or you can go back to the other video. We also used that time in order to determine our horizontal displacement. Again, all of the work is here. Feel free to go ahead and pause or return to that video for more explanation. Now that we're looking for the peak height or maximum height, we know that the maximum height is something that is a vertical piece of information. So when we look at this chart over here, all of this information is vertical information, but it involves all of the time that it's in the air, not just for the peak height. So we are going to make a new chart for just the maximum height information. So when we look at Y information at max height, I always like to make a separate little chart so that I'm not confused by our values. So we are still going to have an initial position at 0 meters. We are solving for our final position. We have our acceleration as negative 9.8 meters per second squared. Again, our acceleration due to gravity. We have our initial velocity is still going to be the 25 times sine of 45 that we solved for earlier. So the 17.7 meters per second. Now, this is where we start getting new information. When we are looking at the very top of a projectile's path, we know that it comes to a brief pause vertically before it turns around and comes back. So this is all the information that we know from our problem. And we're going to solve for that top position. We have everything except time. So we are going to use the very last equation on the AP Physics 1 formula sheet. We've got v squared, v initial squared, plus 2a x minus x naught. Now, if you would prefer to use the variable y, that is totally fine, and you can do that. It's not going to change the impact, the outcome of your problem. So we have 0 equals 17.7 meters per second, and we are going to square that. We have adding to negative 9.8 times our final position, knowing that our initial position is 0. So we can just get rid of it. So 17.7 squared will be 313.29, and then we have negative 19.6x here. So we can move that to the other side. And then we will divide both sides by 19.6 to get our final position by itself, and that will be 15.98 meters. So that means that at the very top of the path, the football has traveled vertically 15.98 meters. Now, there is a second alternative way that we could go through this problem, and it depends on the fact that the football is starting and ending at the same spot. So because we have a position vertically of 0 and a final position vertically of 0, we can see that there is symmetry in this problem. So we can go ahead and split that right down the center, and we can say that it takes the same amount of time to get to the top as it does to get to the bottom. And again, that's only because we're starting and ending at the same vertical position. So we can take the time that we solved for earlier, and we can use that in our max height equation. So we're going to go ahead and do that together as an alternate for this process. So if we know that the total time to get from point A to point B is going to be 3.61 seconds, and we know that it takes the same time to get to the top as it does to get back down to the bottom, we can just go ahead and divide that in 2. So this is time 1/2. So we would have 1.805 seconds to get to the very top. So if we go ahead and look at our formula sheet, we can use the long formula here x equals x initial plus our initial velocity times time plus 1/2 at squared. And from here, we're just going to go ahead and plug in all the information that we know again. So we have our initial velocity of 17.7 meters per second. We're multiplying it by our time that we again halved from our full trip. Then we have negative 9.8 meters per second squared here. And then we have 1.805 for our time, and we're going to square that. Sorry that we went into our chart a little bit. So we can go through it this way, and we'll end up here multiplying 17.7 times our time, which gives us 31.9485. I didn't simplify that this time. And then for the second part, we end up with negative 15.964, and we're just going to go ahead and subtract those two quantities. So now we finally end with a final position of 15.98 meters, which we saw was the same when we did that using the other equation.